Welcome to nth roots and rational exponents. Today we're going to talk about how you can write radicals or roots as exponents. So the first thing that we're going to talk about is our main idea, how you write a radical as an exponent. If you notice, when I have the nth root of x to the m, I still have x, that main number, as my number, but the number that's on the inside, so your whole exponent goes on top. The number that is your root is going to go on bottom of the fraction, and then it turns into x to the m over n. So we're going to try a couple of examples. Before we do that, I need to refresh your memory of some things that you've learned in the past about what perfect squares, perfect cubes, perfect fourths, and then we have a fifth and a sixth down here. So if you don't remember these numbers, this would be something good to copy down because we're going to start changing our numbers. For example, if I have 49, I'm going to change it backward to 7 squared. If I have 125, I'm going to change it backward to 5 cubed. So the first thing I'm going to start with is a couple of examples here. I'm going to write them as radical exponents or fractional exponents. My first one, the number inside of the radical is y. So that's going to be my base number. That's the big number. The number inside goes on top of my fraction. The number that's my root is the bottom of my fraction. So the cubed root of y squared is the same as y to the 2/3. Now we're going to try one that has a number. The difference between having a variable and a number is we need to change the number down to its lowest terms. As in that last piece of paper that I showed you, we need to look and see, well, we need to find what 32 is and how else we can write 32. If we look back at this paper, I see 32 down here is the same as 2 to the 5th. So since 32 equals 2 to the 5th, it's the same as having the fourth root of 2 to the 5th. So what I'm doing is I'm replacing the 32 with its broken down form. And then I'm going to write it with the fractional exponent. So my base here is 2, the inside number is 5, so it goes on top, and then the root is 4. So that's the same as 2 to the 5/4 power. So I have a couple of examples here I would like you to try, and then I'll show you how to work it out. First one, remember your top number is the one inside, the bottom one is your root, so this turns into x to the 5/3. What I really want to show you is the one that's 125. If you look back at your perfect numbers, 125 equals 5 cubed. So we can write this as the cubed root of 5 cubed, which would give me 5 to the 3/3. What we need to do now is we need to reduce the fraction. 3/3 reduces to 1, so this is just the same as the answer of 5. So now that we had the radical and wrote it as an exponent, now I'm going to give you the exponent and write it as a radical. So the 8. The 8's going to be the number inside. We see the number on top is the exponent that's inside. Since it's 1, I don't need to write it. And then the 5 is telling me what the root is. So this is the same as the 5th root of 8. When we have 2 to the 3/7, I'm going to draw my root. 2 goes inside. The number that's on top is my exponent that's on the inside. The number that's on bottom is my root. So 2 to the 3/7 is the same as the 7th root of 2 cubed. Now I have another example for you to try. So this will be the same as the square root of 4 cubed. So now what we're going to do is we're going to use rules of fractions to actually simplify down some of these expressions. Again, very important to go back to this piece of paper that has all of our perfect numbers. Our number here is 81. So if I look on here, I have 81 here as 9 squared, or I also have 81 over here as 3 to the 4th. I would prefer you write it down as its smallest form, which would be 3 to the 4th. So what we're going to do, since 81 is 3 to the 4th, I'm going to put 3 to the 4th here, and then to the 3/4 power. So again, I'm just putting the 81, whatever that value is, in parentheses, and I take it to the 3/4 power. If you remember, if you take an exponent to an exponent, you have to multiply those. So I can go off to the side and take 4 times 3/4. Make 4 a fraction. If you remember when we were just multiplying fractions, cross cancel. So this ends up equaling 3. So all that means is when I multiply these two together, still have the base of 3, but my new exponent is just 3. So then I find out the answer of 3 cubed is 27, and that's my final answer. Let's go ahead and try one of these again to make sure we get the idea. The first step here, we look at our base number, which is 16. I'm going to refer back to my paper here. I look at 16, I can write it as 4 squared, or I can also write it as 2 to the 4th power. I would prefer 2 to the 4th power. So I'm going to replace the 16 with 2 to the 4th power, but still have this negative 3/4 there as my exponent on the outside. Again, exponent to an exponent, I need to multiply these two exponents. So I'm multiplying those two off to the side. 4 times negative 3/4. Again, the 4 becomes a fraction as 4/1. I can cross cancel. And so my answer is going to be a negative 3. So when I multiply those two, that I keep the base of 2, but then I have negative 3 as an exponent. So we need to remember, well, how do we figure out 2 to the negative 3rd? Negative means reciprocal, so that's the same as 1 over 2 cubed, which would be 1 over 8 as my final answer. And then here are a couple problems I'd like you to try to work out.